All right, we're going to look at quadratic word problems. We've done this before, but we're going to look at the vertex form aspect of them as well as the standard form aspect. So if you were given this scenario, a football was kicked starting at 3 feet off the ground. The picture below shows the path of the ball. What does the point represent? All right, there's different ways that you could answer this question. You could say how high the ball got before it started coming down, the maximum height of the ball. But for what we've been talking about in here, standard form or vertex form, this height of the ball would be the vertex of the parabola. And if you know anything about vertex form, it is written as a point in the form h comma k. Now that comes from our form a times x minus h squared plus k. All right, so just looking at this picture here, if I go to this next slide, it asks you another question about the ball. It says, it gives you h and k for the vertex up here. So again, this is the vertex. All right, and it asks two questions. It says, what does h and k represent? So if you look at this, the h is in the location of the x's, which are down here. So when we've talked about these word problems, the x values have all been time. All right, so the h can represent the time it takes the ball to get to the top, or the time it takes the ball to reach its maximum point. And the k value is the y value. All right, so over here are the y values. So the k is up here. All right, so that means that k would represent the maximum height of the ball. So h is the time it takes the ball to reach this maximum height, which is represented by k. That's why h and k go together. All right, so if we look at these quadratic word problems and you look at the notes that I gave you, it says on this first slide, this is a really good slide because it gets into a lot of detail. It says, if we apply this to real life, our graph would look like this. It would be an upside down view, just like that. Okay, because anytime you're going to launch something, kick something, throw something, it's got to go up in the air and come back down. It wouldn't go down and come back up. All right, so this is what it's going to look like if it's thrown. H and K would really be time, comma, height. So look at this. Time right here is in the place where h is, and height is in the place where k is. Now that can be really more specific because the h is the time it takes to reach the maximum height. All right, because up here at the very top, this vertex is really the max height, which is k, and how long it took to get there, which is h. Okay? So h is how long it takes to get there, k is the height, because the h's are the time values or the x values, and the k's are the height values or the y values. Okay? So, if we go down here to this first example, just remember that h is your time and k is your height when you're talking about h and k in the formula. All right, so before I start this, I want to actually move this down. I got a couple of things that I want to write down up here for you to write on your sheet of paper. First of all, I want you to write the vertex form equation. F of x equals a times x minus h squared plus k. So if you're given an equation in this form, all you got to do to find the maximum height, the point, is look for h and look for k. H would be the time it takes to get to the highest point. K would be how high it actually got. All right. Then I also want you to write this. Okay, just as a reminder, h comma k. H is your time, and k is your height. So write that down so you don't get confused and think that h is actually the height. All right, so this example 1 says the height of a ball, h meters, t seconds, after it is thrown, is given by the equation h equals. So this h right here is in the f of x location. So it's not the same as the h inside our parentheses, because you can see inside the parentheses we have the number 3. Okay, but the equation is h equals -5 times t minus 3 squared plus 46.5. All right, and the question is, what is the maximum height of the ball? So if we're looking for the maximum height, that's telling us find what k is. And if you look, -5 is a, 3 is h, positive 46.5 is k. So to answer this question, the maximum height of the ball is 46.5, and this says meters up here, so it'd be 46.5 meters. That's all you'd have to do for part A. If you look down at B, B says, how long does it take the ball to reach its maximum height? How long? Now, long is asking you about time. And in this case, it wants to know the time to get to its maximum height. So it's asking you to find the h value. Well, if you go back up and look, we said that h was the number 3. All right, and time in this case is in seconds, so you would say 3 seconds. Now, if you think about everything that we've talked about with quadratics, especially word problems, ones that have to do with time, you would not write -3 seconds. Remember, we write the opposite, h. Okay? And in this case, it makes sense because -3 seconds does not make sense. It's negative time. You cannot have negative time. All right, so even though in the equation it says t minus 3, it's not -3 seconds. Remember, the h on the inside is the opposite of what it looks like. So since it says -3, h is positive 3. Now on the outside, we're fine to say that k is positive 46.5 because it is positive. All right, but how long does it take to reach the maximum height? That is the h value, the time to get to the maximum height, and in this case, it's 3 seconds. Now in this example, finding these things was pretty simple because it's in vertex form. We can see the a, real easy, it's -5. We can see the h, real easy, it's positive 3. And we can see the k, real easy, it's positive 46.5. But what happens when our equation is in standard form? Like on example 2, that's standard form. -16t squared plus 12t plus 320. Remember, that's like ax squared plus bx plus c. All right, so if we're looking at this one, let's just start by reading the example. James jumps off a cliff into the ocean. His height as a function of time could be modeled by the function h of t equals -16t squared plus 12t plus 320, where t is time in seconds and h is the height in feet. All right, so the first question is, how long did it take for James to hit the water? Okay, this is one of those questions right here. Part A is asking you this. All right, he jumps from here, he's hitting the water right here. That's an x-intercept. So to solve this one, we need to use the quadratic formula. Okay, this is not asking us about h and k. It's not asking us about the highest point yet. All right, it's asking us where did he hit the water. Okay, so let's use our quadratic formula to figure that out. So I'm going to go back up here for a second and look at my original function, and I'm going to label A, B, and C, because I need all three of those for the quadratic formula. Make sure I get the signs right. A is negative 16, B is positive 12, and C is positive 320. So that cliff was pretty high. I started out at 320 feet. All right. So for part A here, and I'm going to have to write it kind of small, we're going to write T equals, all right, because we're looking for time. We'll make a big fraction. We'll go with opposite B. We've got negative 12. We've got plus or minus the square root. And underneath that square root, we'll have B squared. And we'll put a 12 in the parentheses and square it. Minus 4 times A, and we'll put negative 16 in parentheses, times C. So in that, next to that, we'll put 320. And all of that will be over 2 times A. So on the bottom, I got 2 times negative 16. So before I go put it in the calculator, let's make sure everything's right. I got 12 as B, so I put negative 12 in the beginning because that is the opposite of positive 12. Plus or minus the square root of B squared. B is 12, put in parentheses, square it. Minus 4 times A is negative 16, times C is 320. All of that is over 2 times A, and A again is negative 16. So from here, it's a matter of putting it in my calculator. And remember, you do not want to have negative time. So when I punch this one in, because I have 2 times negative 16 on the bottom, instead of doing the plus first, I'm going to do it with the minus on top. So I'm going to go negative 12 minus the square root of 12 squared minus 4 times negative 16 times 320, and all of that is over 2 times negative 16. All right? And when I punch that in, it comes out to positive 4.86. All right? And 4.86 would round up to about 4.9, and in this case, time is seconds. So 4.9 seconds. That's how long it would take him to hit the water. Okay, so that picture I just drew a second ago, it would come down and land at the surface of the water, which would be the x-axis. All right, that's why this question has a star next to it, because you never know what it's going to ask you. Now, the next question says, what was James' height after 2 seconds? Now, seconds in this case are the t values. So what this one wants you to do is plug in the number 2 for all of the t's. Plug a 2 in for all of the t's. So if we're going to do that, we start out with negative 16 t squared. So in that parentheses, I'm going to stick a 2. Then we have plus 12 times t. Again, in that parentheses, I'm going to stick a 2. And then we have plus 320. So if I want to find out his height after 2 seconds, all I do is put that 2 in for t, and then I punch it into my calculator. So I would start with negative 16 times 2 squared plus 12 times 2 plus 320, and I get 280 is his height. Now, his height in this case is in feet, so this is 280 feet. 2 seconds after he jumps, he's still 280 feet above the surface of the water. Okay, so these first 2 questions really have nothing to do with vertex form. The first one lets you take that standard form and solve it because it wants to know where it hits the ground. Remember, solutions to quadratics are x-intercepts. And he would hit the water, where he hits the water would be an x-intercept at 4.9 seconds. The second one wants to know how high he is after 2 seconds. So take that 2, plug it in for t, you'll figure out his height. Now, C and D, and then you can see I've given you the equation again. C and D go with your vertex form items. All right, so C asks, how long did it take for James to reach his maximum height? How long? Remember, that's time. So time was our h value, because remember, our vertex was h comma k, and h was the time it took to reach the maximum height, which was k. All right? So, for this one, we want to find h. Now, if you remember back to going from standard form to vertex form, the first thing we did was we labeled A, which is negative 16, and we've already done this. We labeled B, which is 12, and we labeled C, which is 320. And then the second thing we did was we found H by doing opposite B over 2 times A. And in this case, the opposite of B would be negative 12. And then 2 times A, we'd have 2 times negative 16. Okay? Now, it's okay if this is a decimal. Doesn't matter. So, when we look at this one, we got negative 12 on top. And on the bottom, we have 2 times negative 16. You should get a positive answer. The fraction you get is 3 over 8. So it would be 3 over 8 seconds. If you want to convert that to a decimal, hit the 2 arrows above the inner sign, and you get 0.375, and this would be seconds. So it's less than 1 second after he jumps that he reaches his highest point. Okay? Now, thing to note here, make sure that your time is a positive number. Again, you would not have negative time anywhere. You would not have negative time anywhere. So make sure when you punch that in, you get a positive time. But that's all you'd have to find, because the h value is the time it takes to reach the maximum height. Now, part D says, what was his maximum height? So really, we have to do our third step from going from standard to vertex form. And if you remember, our third step was to find k. And in order to find k, we take h and we plug it back in. And in this case, we're going to take that h and plug it in for both of these t's. So, let's set that up. Starts with negative 16 t squared. In that parentheses, I'm going to put 0.375. Then it was plus 12 times t. And again, in that parentheses, I'm going to put 0.375. And then, at the end, it was plus 320. And to find out what k is, I punched that into my calculator. Now, obviously, k is going to be a little more than 320 because that's where you started. All right? So, let's see. We got negative 16 times 0.375 squared plus 12 times 0.375 plus 320. And it gives us 322.25. That makes sense because you started at 320. Remember, the number in the back is where you start. You jump up, it goes up a little bit, and we only went up for 0.375 seconds, so there couldn't go up much. So the maximum height here is 322.25, and I believe, what is this? Yep, 10 feet. So the highest point here is 322.25 feet, 322.25 feet. So the big thing here is make sure you know what it's asking. If it's asking for the maximum height, it wants you to find k. If it's asking you how long it took to get to the maximum height, it's asking you to find h. If it wants to know where it landed, where it hit the water, use the quadratic formula and solve the equation. It wants the x-intercept. If it wants the height after a certain amount of time, plug that number in for your letter and solve. Got any questions? Make sure you come see me.